You are welcome to the Scholar School. We establish our footprints on the sand of time. Experience the difference.
Hi, welcome to the Scholar online class. My name is Abiola Daniel. So today I'll be taking us through mathematics. Now we have a question here in short. Looks a little quite complex, but we are going to solve it and we all get to understand them better. Now we have just a question here. So it looks like as if it's more than 20, but just a question. Now we have solved the square root of x, the square root of x, then root x, root x, root x, then root x. Now to solve this question, all you need to do, you must have the basic knowledge of the laws of indices. Now, how do we solve this question? The first thing is to start from here, then we'll do it backwards. Now, for the first one, we have our x. So I'm writing it here. Our x. And our x has a root. So we have 1 over 2. Then we give it another bracket. It's multiplied by x. So we put our x here, then our bracket. The x is still raised to power 1 over 2. So we put 1 over 2. We still have another x here, then we give it another enclosed bracket. Raised to power 1 over 2, we put it 1 over 2. Then we have our x here in an enclosed bracket 1 over 2. Now we have 1, 2, 3, 4. 1, 2, 3, 4. Then the last one, we have our x. Then in the closed bracket 1 over 2. Now this is the interpretation of the question. So the next thing we need to do is to take this one after the other. Now the x here only have just it has all the values here. That means the x here only have just the 1 over 2. That means the more it increases, the more the values for x here decreases. That means the x here has the highest value of the power. This has the next value. This has a bit lower. Then this has the lowest. So now we have x raised to power 1 over 2. Then here we have x raised to power 1 over 2. The same thing, 1 over 2, 1 over 2, 1 over 2. So now, if x is raised to power of 1 over 2, then this will be the addition of the 2. We continue adding 1 over 2, the half, and so on. But here we are now applying a law of indices, which states that a raised to power n, a raised to power n, a raised to power m is equivalent to a raised to power n times n. So that is what we are going to apply here. So here we have our x here, which is raised to power half, times our x here, which is raised to power 1 over 4, times our x here, which is raised to power 1 over 8, times our x here, which is raised to power 1 over 16, times 1, 2, 3, 4. 1, 2, 3, 4. Then the last, our x here, which is raised to power 1 over 32. So then this is another law of indices. So we add them all together. So we have our x raised to power 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32. So the next thing we have is x raised to the power of, we find the LCM, which is 32. If the LCM is 32, then we have 32 divided by 2, which is 16. So we have 16 plus 32 divided by 4, which is 8. We have 8. 32 divided by 8, which is 4. We have 4. Then 32 divided by 16, which is 2. We have 2 plus 32 divided by 32, which is 1. So we have our final answer here to be 16 plus 8, which is 24, plus 4, which is 28, plus 2, which is 30 plus 1, which is 31. So we have it to be x raised to power 31 over 32. And this is the final answer to solving this question. All you need to do is to reverse the process. Start from x. When you take x, you give it its power 1 over 2. Then you are now raising the power of a, you multiply by your x, then you give it its own power, which is 1 over 2. That means the power of x here as 1 over 2, and likewise this 1 over 2. Now, when you continue, you take the next one, which is x, which is this, then you give it its own power, 1 over 2. That means the more you give the enclosed bracket power, the more the power of x within here increases. The more the power of x within here increases. Now until the highest one only has its power to be 1 over 2. That's why it has 1 over 2. The next one has two powers enclosed. It has two powers enclosed. You have 1, 2, which is 1 over 2, 1 over 2. And that is x raised to power 1 over 2 times 1 over 2, which is 1 over 4. Then, like that, then the power continue to increase. And that's how we are going to do it. So we interpret it this way. X raised to power 1 over 2 times x raised to power 1 over 4 times x raised to power 1 over 8 times x raised to power 1 over 16 times x raised to power 1 over 32. Then we find, we add them all together using the laws of indices. We find the LCM and our final answer expressed in this form. That means when you have a question that is this, the square root of 2, root 2, root 2, root 2, square root of 2. In this form, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All you need to do is to take this. Your x is 2 raised to power 31 over 32. And you are good to go. And that's how to apply that in solving questions. Now, we have a question here. Find the square root of 15 plus 3 root 2. Find the square root of 15 plus 3 root 2. That means to solve this, this is interpretation of the question. 15 plus 3 root 2. Now, to be able to solve this question, we can't just venture to solving this question. We need to represent this question with some identities. We equivalent this to a plus root b, where a is the rational number and root b is the irrational. Now, so the next thing we need to do here is to find the square of both sides, because this is equivalent to 15 plus 3 root 2 raised to power 1 over 2, which is a root b. Yes. Now, finding the square of both sides means you are multiplying by 2. Then here, 2. So we have our 2, eliminate our 2 here. So we have 15 plus 3 root 2 to be equivalent to a plus root b or square. So the next thing we continue to do is to be able to expand the right hand side. So we have 15 plus 3 root 2 to be, this will give us a plus root b times a plus root b. So we have our 15 plus 3 root 2 to be a square plus a root b plus a root b plus b, because the square root of b multiplied by the square root of b will give us b. So we have 15 plus 3 root 2 equals a square plus a root b plus a root b will give us 2a root b plus b. Then the next thing we do is to rearrange all rational number on the left, or all rational number on one side and the rational on the other side. So we have 15 plus 3 root 2 equals a square plus b plus 2a root b. So the next thing we move to is what we call the comparison rule. We have to compare a square plus b, because corresponding with 15, we equate it to 15, and likewise the rational to the rational. So we have a square plus b to be equivalent to 15, and likewise our 2a root b to be equivalent to 3 root 2. So from here, we can now start solving. Now the first thing is to turn from either of these two equations. So I prefer to take equation 2. Since I have 2a root b equals 3 root 2. Then I find the square of both sides. That means I have to square both sides. So I have this. So I will have 4a square b equals 9 into the bracket of 2. So I have my 4a square b equals 18. Then I divide both sides by 4. So I have my a square b to be equals 18 over 4, which is 9 over 2. That means my a square b equals 9 over 2. So the next thing I also do is to divide both sides by b. So I have a square to be 9 over 2 times 1 over b. So I have 9 over 2b. That is for a square. And in my question, I have my a square plus b from equation 1. A square plus b equals 15. Then I can just substitute. So here I have substitute 9 over 2b for a square in equation 1. So since my equation 1 is a square plus b equals 15, then I have my a square to be 9 over 2b. 9 over 2b plus b equals 15. So I can find the LCM, which is 2b, then 2b eliminate 2b, we have just 1. Here we have 9 plus 2b divided by 1, that is 2b. 2b times b, that is 2b squared equals 15 over 1. And as you can see, you will see and notice that this is already leading to a quadratic equation. So we continue. Next thing we do is to cross multiply. So we have 9 plus 2b squared equals 15 times 2b. So we have 9 plus 2b squared equals 30b. Then we collect like terms and we have 2b squared minus 30b plus 9 equals 0. This is a quadratic equation. So we continue to solve. Then the next thing we move on to here is since we have 2b squared minus 30b plus 9 equals 0. Now in quadratic equation, we multiply 9 times 2, which is 18. Then two numbers that when you add them together, it gives you 18. And when you multiply, they gives you two numbers that when you multiply together, they gives you 18. When you add together, they give you minus 30. So the two numbers here, we don't add them. So we can't use factorization method, but rather we use the quadratic formula, which states our x to be minus b plus or minus into the square root of b square minus 4ac over 2a. So we have our minus b to be minus 30 plus or minus our b square, which is minus 30 square minus 4 times 2 times 9 over 2 times 2. So here we have our 30 plus or minus the square root of this will give us our 900. Then this 18 times 4 gives us our 72. So we have 900 minus 72 divided by 4. So here we have 30 plus or minus the square root of 828 divided by 4. So here it could now be 30 plus or minus into the square root of, okay, could be 30 plus the square root of 828 divided by 4, or 30 minus the square root of 828 divided by 4. Now, this will be our value for B. So we have two values for B and we are picking one. We have two values for B and we are picking one. So the next thing we now need to do is to now find our A. We have our A to be 9 over 2B. 9 over 2B. So we are now going to substitute for each of these. Substitute for each of these. If our A square equals 9 over 2B and our B is 30 plus the square root of 828 over 4. So we have 9 over 2 times 1 over 30 plus the square root of 828 over 4. So here you have 9 over 2 times 4 over 30 plus the square root of 828. So here we have to eliminate 2 out of 4 here, we have 2. So we have 9 times 2, which is 18 over 30 plus the square root of 828. Now, here we still have our A square. So the next thing we need to do is to find the square root of both sides, so that our A will be the square root of 18 over 30 plus the square root of 828. So this will be our first value of A when B is 30 plus 828 over 4. When B is 30 plus 828, the square root of 828 over 4, we have our A to be square root of 18 over 30 plus square root of 828. Now, the next thing we are going to do is to substitute when our B is still 30 minus 828 over 4. When our B equals 30 minus square root of 828 over 4, we have our A square to be 9 over 2 times 1 over B, which is 1 over 30 minus square root of 828 over 4, which will give us 9 over 2 times 4 over 30 minus square root of 828. So 2, here we have 2. So we have 18 over 30 minus square root of 828, which is still A square. So our A here becomes the square root of 18 over 30 minus square root of 828. So now when our B is 30 plus 8 square root of 828 over 4, our A was 18 over 30 plus 828 over 4. So in this case, the square root of our question will now be, since we have it to be in form of A plus root B. A plus root B. So in this case, we take our A. The first one, we take our A, then the square root, then we put our B. That means our A, which is the square root of 18 over 30 plus the square root of 828 plus the square root was our B, 30 plus the square root of 828 over 4. And this is how to solve the question. So this will be our final answer. And most of the times, we do have questions that don't always arrive at this kind of large figure. So we might have questions that might land up us in getting like 2 and 3 as our A and B. But in this case, we arrive at our final answer to be 18 over 30 plus square root of 828 plus the square root of 30 plus 828 over 4. That means when you punch your calculator, when you punch the square root of the number of the question given, and when you add these two together, we are going to get the same thing. That means the square root of the question given is equivalent to the square root of this plus the square root of this, and that's how to solve questions like this. And so thank you very much for watching.